Hello, welcome to room 261. Let us get our act together here. Today's lesson is on the law of cosines. I'm not really sure why my face is not showing up on the screen today, but maybe you're tired of looking at my face anyway. And so that's cool. We're going to use the law of cosines to solve triangles in the side angle side and side cases. We're going to talk a little bit more in person about the proof of this law. However, for the purpose of this video, we're just going to let you know how to use the law of cosines to solve some triangles. You can see that I have the formula written here. Um, it's also true that you could solve that formula for cosine C. You could have solved it for any of the letters. And so anyway, I'm just going to show you here on the screen that, you know, these are also different versions of the same law, okay? And so you can see a pattern here. C squared equals A squared plus B squared minus 2AB cosine C. If instead you wanted to find side B, you would use this version. If instead you wanted to find side A, you would use this version. If you were given three sides, the side case, and you wanted one of the angles, you would use one of these versions. Okay, so let's talk this over here. So suppose that we want to solve triangle ABC if maybe we know A is 10 and B is 7 and angle C is 31 degrees. Okay. And so just sort of pause and think if you want and tell yourself that you really can't use the law of sines in this case to find anything because you don't have three of the four parts of a proportion. So we're going to use the law of cosines, and in this case, we want to use the one that starts like this: c squared equals a squared minus, or a squared plus b squared minus 2ab cosine c. And so it really isn't too bad. We're just going to put in the numbers where they go. And so a is 10, and b is 7. And we can get out our calculator. And so we're going to get our calculator here, and we'll make sure that we're in degree mode, and we are. And so we're going to hit 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of 31. And so I get this number, but now remember that's c squared, and so I got to take the square root of that number. And so that means that c is 5.385 to the nearest thousandth. Now, at this point, we've got choices. We got to find angle A and angle B yet, and so but yet we have one other piece of information. So we could either use the law of cosines or the law of sines. Let me just say that the law of cosines in some ways is safer. It never gives you the wrong answer. The law of sines, the advantage of it is that it's quicker. And so the thing about the law of sines, and I'm going to write this down, and I want you to pause this and listen to it more than once. But if you use the law of sines at this point, use it to find an angle you know is acute. Okay, you might recall that the law of sines can be a little vague with that side angle case. You might also recall facts such as the sine of 60 degrees is the same as the sine of 120 degrees, and so your calculator doesn't know which one that you want when you're looking for an obtuse angle, and so it always gives you an accurate answer when you know the angle is acute. And so in this particular problem, we need to find either angle A or angle B. We know angle B is acute because B is smaller than A, and so that's exactly what we're going to do. We're going to find angle B. So sine of B over 7 is equal to the sine of C over little c. And so let me just say that again. We found the sine of b over b equals the sine of c over c. That's the law of sines. Now, we are going to use the stored value. Okay, we don't round as you go. So don't round as you go. We want to use the stored value here. And so let's get our calculator out. And we're going to say that 7 sine 31 divided by our stored value. So divided by answer. That's equal to the sine of b. Now, if I'm going to find b, then I need to use sine inverse. So sine inverse of that number is going to be 42.03 degrees. A lot of times we round our angles to the nearest tenth, so it's 42.0. And so then all that's left to do here is to find angle A. And so angle A is 180 minus the number we just found, minus 31. And so that's 107.0 degrees. I want you to notice that one was obtuse. If we would have used our calculator, or pardon me, if we would have used the law of sines to find angle A in this step instead of angle B, we would have gotten wrong answers. It would have given us 73 degrees, and as you can see, 73 degrees is not the answer. And so make sure that you pay attention to this advice here if you're going to use the law of sines to find the second piece of your puzzle. Okay. Again, the law of cosines will always give you the right answer. And so if you wanted to use the law of cosines all the way through, you could have. The law of sines is like a new friend that you just met that is cool and is fast and is like has a lot of great ideas and seems like they're a lot of fun. And the law of cosines, on the other hand, is like that old friend that you've had forever, and might not be as much fun, but you can totally rely on. And so every now and then you get a new friend, and they're fun, and you think you're going to go do something fun on Saturday night, and you give them a call, and then they're no longer available. Whereas your old friend is steady and always available. And so that's like the law of cosines. All right. So enough of that nonsense. Let's continue here, and let's use the law of cosines to do a side problem. And so suppose we want to solve triangle ABC if little a is 11 and little b is 13 and little c is, say, 14. Now, much in the same way we talked about before, if if you want to think ahead to where you want to use the law of sines in the second step, then in that case you would use the law of cosines to find the largest angle first. So in the side case, the staff in room 261 recommends finding the largest angle first. Now, the staff in room 261 is 51 years old, and the students in room 261 are 17. And so, like, since you're 17, you probably know everything there is to know, and so you do whatever you want, unless you trust the staff in room 261, and then you pause and follow this advice and listen to it maybe more than once. Anyway, we're going to find the largest angle, and so the largest angle is going to be angle C. If you look at the formulas that were given to you, the cosine of C is equal to a squared plus b squared minus c squared over 2ab. And so in this case, it's 11 squared plus 13 squared minus 14 squared over 2 times 11 times 13. And so it's calculator time, right? And so we're going to get out our calculator. And I'm just going to do this in one fell swoop this time. cosine inverse. Okay, I'm going to make a fraction bar. 11 squared plus 13 squared minus 14 squared all over 2 times 11 times 13. All right, and then if I hit enter, that's going to give me the angle. It happened to be acute, but sometimes if it were obtuse, it would have given it to me just fine. So angle C is 70.8 degrees. Now I could use the law of sines or the law of cosines to find the next angle. Okay, we'll just go ahead and use the law of sines. So the sine of C over 14 is equal to the sine of, say, B over 13, which is to say that B is the sine inverse of 13 sine C over 14. Now C, remember, is the number we have on our screen. And so we're going to hit sine inverse, 13 sine, and in this case we'll hit answer since I didn't store it, divided by 14. And so we're going to get 61.3 degrees. Okay. Let me do that again just so you can see it a little better. We could have used the fraction bar. You'd see it better on your screen. It was 13 sine of C, which that was this number here, and then divided by 14. And so again, you get this 61.3 number. So now we've got C and we've got B. And of course, A is 180 minus B minus C. And so that's 180 minus that number I just found, and then minus the number I had earlier. And so you can see that that's 47.9 degrees. And so you could double check to make sure that those angles all add up to 180. That's not such a bad idea at all. All right, let's do another one. So suppose instead I gave you A to be 20 and B to be 5 and C to be 6. And so furthermore, let's say that you're hanging out, you're doing your homework, but you're checking your TikTok and you're messing around with your Instagram and you're not really paying attention. And you've done a couple of these problems and you crank out the formula and you say that cosine A is equal to B squared plus C squared minus A squared over 2BC. That's the formula. All right. Now, let's just get out the calculator right now and crank this out. So if I hit cosine inverse and I do B squared, so 5 squared plus 6 squared, so B squared plus C squared minus A squared over 2 times A, or B times C. Now, let me just tell you that, I am not checking my TikTok page or my Instagram account, and I'm here to tell you we're going to get an error here. Whoa! And so I better stop and think about why I would have gotten an error. And so maybe you can pause the video for a second and ask yourself why we got an error. All right. But instead, welcome back. And so anyway, the reason we got an error is because there's no such triangle with these dimensions. Imagine that, like the distance from Carlinville to Girard is, say, 20 miles. It's impossible to find a shortcut where it's 5 that way, it's 6 this way. There's just no way to make a triangle like that. So this is an impossible triangle. All right. So you might remember something called the triangle inequality from geometry class. The reason there's no triangle here is because the two smaller sides have to add up to be larger than the largest side. Okay, the sum of the two smaller sides have to be larger than the largest side, and that's not the case here. And so that's why this is impossible. Okay. I think at this point, I'm going to leave you to the rest of your assignment, and then maybe you'll have some questions on story problems or whatever, or maybe even on finding the other the other items, but this will get you started on the law of cosines. Hope you enjoyed the video here in room 261, and we'll catch you again soon.